Find the derivative of arcsinch x over a, or arcsine of x over a, and the derivative of arccosh of x over a. Okay, starting with the derivative of arcsinch of x over a, if we let y be equal to arcsinch x over a, that means that sinh of y will be x over a, and therefore if we differentiate implicitly, we're going to get the differential sinh, which is cosh y dy by dx, is equal to the differential of x over a, which will be 1 over a. Rearranging that will give me dy by dx is 1 over a cosh of y. Right, standard thing here, cosh squared of y minus sinh squared of y is equal to 1, which means that cosh squared of y is 1 plus sinh squared of y, and therefore cosh of y is the square root of 1 plus sinh squared of y. Now we only need to consider the positive square root because the gradient of is always positive for both arccosh and arcsinch. Right, so now replacing cosh of y with this, we get 1 over a times the square root of 1 over a times the square root of 1 plus sinh squared of y. Now, sinh squared of y, sinh of y is x over a, so sinh squared of y will now become 1 over a square root of 1 plus x over a, all squared. Right, we need to be a bit careful here. So this becomes 1 over a. Now, if I square this, I get x squared, a squared, and I put this up here, I get a squared, I get a common denominator of a squared, so I get a squared plus x squared over a squared. Now, what I'm going to do now is take that out. When I take that out, these two will now disappear, because when I take out an a squared, it becomes a of the square root sign, and a over a is 1, so that disappears. So I get dy by dx is 1 over the square root of x squared plus a squared. So ddx of sinh of x over a is equal to 1 over the square root of x squared plus a squared. Now, interestingly, of course, there, if you have to integrate that, then it's going to be equal to that. This is where it's most useful. Now, ddx of arccosh of x over a, same process, let y be equal to arccosh of x over a. Therefore, cosh of y is equal to x over a. If we now differentiate implicitly, if you differentiate cosh, you get sinh or shine. Sinh of y, dy by dx, and differential of x over a is 1 over a, and therefore dy by dx, which is what we want to find, is 1 over a sinh of y. Now, using the identity of cosh squared of y minus sinh squared of y is equal to 1. I proved this identity in a different video. And therefore, sinh squared of y will be cosh squared of y minus 1. Therefore, sinh of y will be the cosh squared of y minus 1. We only need the positive value of the square root because the gradient of this is positive throughout. Right, so now replacing sinh of y with square root of cosh squared of y minus 1. The cosh is equal to x over a, so this will be ddx of a over x over a squared minus 1. Now, doing a similar trick like we did before, that becomes x squared minus a squared over x squared. When you take that a squared out, these a's cancel. So dy by dx will be 1 over square root of x squared minus a squared. And therefore we can say ddx of arccosh of x over a is 1 over the square root of x squared minus a squared. And then interestingly, of course, if you integrate that, you get back to that, where perhaps it's more useful. So this has been a video where we have shown the derivative of arcsinch of x over a and arccosh of x over a. I hope you've understood, and I thank you very much for watching.